All right. Thank you very much, Russ. So it's been a couple years since I've seen you folks. It was the last book. It's another book that brings me here. But I was down on an in-person tour. I'm sure a couple of you remember Esteban and Russ. I know that you remember. I did probably about 4 different cities down there in Florida. It was one of the best part of the tours in the country. I really did enjoy it.
Yeah.
So it was a good trip. So it's great to see you folks again. So as Russ said, today is going to be about machine learning. And as he also said, I've been spending a considerable amount of my time over the last 5 or 6 years in mobile app development. And I have sort of done all kinds of things in terms of development, in terms of courseware, in terms of helping shops to make things happen in mobile, particularly with Xamarin, C#. And so it was time to start to do some things, layer some things on top of that. And I was having more and more clients ask about machine learning. And so it just sort of suddenly came. I mean, I knew I had to learn a little bit more about it, and I knew I had to start working within it. But then I started working closely with Microsoft on a series of courseware for actually high school students. It was specifically for the future farmers of America, basically helping them to grow plants using AI. It was the coolest thing. Really good project. So I knew it was time for me to start really talking to developers about how we do these things and how we can make them happen just in simple little apps, in simple mobile apps, most specifically. You can, of course, do these things in desktop apps, but me having my background in mobile and in Xamarin, I wanted to do it that way and see if I could get it on a phone. And so that's what this presentation is about, is really about getting AI onto a device and making it happen. And before we get into this, I know that Russ has a couple of surveys he wanted to give. Do we still want to do those, Russ? Yeah, you got them right here.
Launch it. Do you see it right now, or do you have to stop sharing your screen to see it?
I can see them right now.
All right, good. All right, so everybody, if you can answer that, how familiar are you with machine learning? A little, not at all, a little, a lot. And then the second, what is your Xamarin level? Brand new, under a year, more than a year. And more than a year, and I'm somewhat. So it looks like we got everybody's a little bit familiar with machine learning. And you got 1 new and 3 more than a year on the Xamarin. All right, that's our stats right now. And I'll go ahead and share that result so you can see that as well. All right, there you have it.
All righty, thank you for that, Russ. Are we all set with that?
Yep, we're good to go.
Okay. All right, so a little bit about myself. I've been a software consultant since 1999. That's when I started my company, Lexicon Systems. I code, I write books, and I lead teams. I love tiki cocktails. I love talking about how to mix a good zombie, how to mix a good Mai Tai. I have a parrot, his name is Chicken. He keeps me company when I'm coding. And I like to make digital art. And so I like to do projections on sculpture these days. And so the most important thing, though, is that I love Xamarin. And I love Xamarin so much that I wrote a couple books about it. And what I'd like to do today is talk to you about how we can use Xamarin to utilize machine learning models. And so I'm going to talk a little bit first about machine learning. I'm going to talk a little bit then about visual cognition, because that's the part of machine learning that we're doing. We're doing the visual part. And then we're going to be able to get your device to see objects and then classify the objects that it sees. So what is machine learning? Really high level. In a nutshell, it's computers that can learn from experience without explicitly coding them to tell them to do things. Back in the 70s and 80s, we had things called expert systems that were really complicated systems where we coded them up from the ground up to do really complicated things. And that was the beginning of AI, but they weren't learning, they were being coded. And so the difference between that and what machine learning is in machine learning, we code them enough to tell them how to learn. and then we run them through different sort of cycles, learning cycles, training cycles, and then they learn enough to be able to make decisions and to be able to make predictions. And if you think about our lives and where we might see some of these, I mean, we see self-driving cars, they're coming, they're on the way. We don't quite see them on the road unless we're, you know, hanging out where they're testing them, but they are coming soon, and those things are complicated. They have to be able to identify pedestrians. They have to be able to identify signs. They have to be able to identify cars under all different circumstances, under different weather circumstances. They have to really be able to think quickly and identify things quickly and make decisions quickly. So self-driving cars is one of the big MLs that's coming up. Smart cities. There are a few cities that are specifically focused on doing this kind of thing. And one of them is Austin, I think Edinburgh in Scotland, and then there are a couple of more in the US. But what these things are is cities that are focused on utilizing the cameras within the city to be able to identify traffic patterns and to be able to identify sort of power use and to be able to route the traffic and then route the utilities within the do you have Robert, Russ, I have a note that says that Robert Illustre needs to be admitted. Do you have that?
I'll take care of that. Sorry, I missed that one.
Awesome. Okay, thank you.
Yeah, hey, Robert, welcome.
So we have whole cities that are starting to sort of manage themselves using their cameras and using the information that they're getting from those cameras all around the city. Google Maps and Netflix, we've all used both of these things. We've already been using ML for years, whether we know it or not. Google Maps has been gathering data on us and is telling us where to drive. Netflix is gathering data on us and it's suggesting things that we should watch. And both of those companies are using machine learning very heavily in order to make those things happen. And so how does it work? Well, the first thing that has to happen is we need data, and we need a lot of data. And in this particular case, we're talking about visual cognitive. So we need pictures, we need images. We then need to clean and prepare and manipulate that data. In this particular instance, I was very careful to come up with very clean, straightforward data. So you won't see much data cleaning in this example, but data cleaning is super important. Because if you have, you hear garbage in, garbage out a lot with this step, is that if you give the model and train the model on bad data or messy data, you're going to get exactly that. You're going to get messy results. So you need really clean, straightforward data. It's just like teaching a kid or anybody, really. It's pedagogy, that you need information that's clear and straightforward so that we can learn and so the machine can learn from that data. So then we train up the model, and I'll go into what's a model in just a minute. And this teaches the machine what you need it to know, or hopefully what you need it to know, in order to make the decisions and make the predictions you'd like it to make. And then we compare that against test data to see how it did. You give it tests, or allow it to test itself on additional images to see whether or not it gets those right, or how right it gets them. And then we have a sort of an iterative step where we start with step 1 through 5, or step 3 through 5, or step 2 through 5, where we just go through this cycle over and over again until you get a model that performs well enough that you can use it in whatever scenario you want to use it in, whether it's a demo, or whether it's production, or whether it's to make a proof of concept, whatever it is. You need to be able to improve it well enough to be able to have it perform. So that's how ML works. Now, I'm not going to go into all of these, but I just wanted to give you some idea of just how broad machine learning approaches are. Some of them are just straight up math, support vector machines, regression, things called naive Bayes classification, hidden Markov models. These are just sort of complex math. When we get over into things called random forests and specific recurrent neural networks, because neural networks is what we're going to talk about today, these are structural. They're still math, but they're structural. And you'll see what I mean when I start getting into them. There's a lot of talk these days about neural networks just because there's been a lot of success with them within machine learning. And so in particular, visual cognition, they work really well. And so we use them a lot. These are some examples of machine learning approaches. And so what are models? Well, models are the machine's representation of reality. Google Maps creates a model of your driving patterns. Every time you go anywhere, it adds data. It looks at what recommendation it gave to you, how well you followed it, exactly where you drove. And it saves this to continue to build a model of your driving patterns until it knows exactly what your driving life is like, and it has a representation of this. Netflix does the same thing with your viewing habits. Every time you watch something, it says, okay, well, he just watched a television show that had action in it. And so it had action, and it also had sort of social considerations. And so then the next day, you maybe watch a movie that has, you know, cartoons in it. Maybe it's a Marvel movie. And so it slowly builds out this model of your viewing habits until it has an idea of what it is that you like to watch. And then it uses this to make recommendations and to also sort of group you in with other people that are similar to you to help make recommendations to all of us that are in a particular group. And so this is how machine learning, this is how models are used within Netflix. And so machine learning is the training of the model. It's how the model learns. And we'll go into great depth as to what a neural network model is. So if you're still wondering, don't worry, we'll get to it. Here's some diagrams of neural networks. Models are designed and optimized, and we can train the models, and we can tell the models how to be trained, and that's called supervised learning. Or we can allow the models to be trained by a program, and that's called unsupervised learning, right? Where we just kind of let the machine go and attempt to train itself. And sometimes that works out well, and sometimes it doesn't. But we're getting better at it, so we keep at it. Data is assigned to categories called labels. Now, this sounds like a really simple idea, but at the end of the day, labels is how we tell the computer, how we tell the machine what something is. Is it an apple? Well, the label is an apple. Is it a dog? Well, the label is a dog. Is it a horror movie? Well, the label needs to be a horror movie, et cetera, et cetera. Drama, comedy, these are labels. And so we'll get into what labels are for and why they're so important as far as training models. And so the way in which neural networks are different from just some of the regular math structures that we use within machine learning is all these layers and all these nodes that they have. And so we can construct different kinds of neural networks depending upon our needs. And we'll go into how to do that. And so there are lots of different types of machine learning. There's machine learning that analyzes audio, that analyzes your voice, that does voice recognition, that does language recognition. There's machine learning that recognizes text, that reads grammar, that does language recognition, that does language comprehension. Lots of different types of sort of cognition within machine learning. The one we're going to talk about is eyes, visual, the way that a machine learning program can analyze the image using its model. It categorizes the image, requires a lot of images to really be accurate. It should be more than 1,000. The particular example I'm going to show you, I had a kind of a premise with the example that I'm going to show you. I didn't spend as much time and as much resources as possible in order to get the best possible model. What I did is, with my hands and with my phone, I came up with a training regimen for this thing in about maybe an hour, maybe 2 hours. So all of the work that I've done to train this machine was done with data that was generated with my own hands, taking pictures against a wall with an Android phone. And so I wanted to show just how little you needed in order to train up a model. And it's not the most accurate model in the world, but for 140 images, it's pretty darn good. So typically you want to use at least 1,000. So we talked a little bit about labels before. We want to be able to tell the computer, we want to be able to tell the machine learner, the model, what something is. And so we want to be able to identify something as a fruit. Perhaps we wanted to identify the type of fruit. So therefore we need to be able to send it images of an apple that are labeled apple. These are image classifiers. So what I want to do first is just a walkthrough of the app, and then I'm going to train a model for you, or show you how we do it, and then we're going to look at how the model's used in the code. Okay, the first thing I'm going to do is I call it the hand signs app. What you need to do is choose an image, a hand image, and the app interprets and attempts to classify that hand, and then it predicts a result. All right, here's Visual Studio. Can you see all that all right?
Yep.
Great. Okay,
I can see that. Mm-hmm.
So here's the solution. Those of you who are familiar with Xamarin Solutions, you know that Xamarin.Forms solutions, we have a Xamarin.Forms folder, our project, that has the XAML in it. And then we have the platform-specific project. Now, this is Android only. I didn't do this for iOS, so that's why you don't see iOS in here. But this is where we put some of the TensorFlow stuff is actually platform specific. So that's why we have it down here. It's got some tiny bit of Java data types in it. Okay, so let's then run this thing. So here it is running. So this is running from Visual Studio. This is in debug mode. And I have a choice to take a photo or pick a photo. Now, the coolest thing to do with this thing is actually to hold up your hand and give it a sign, give it a thumbs up, give it an okay sign, give it a wave, and then actually take a picture of that right in front of your face, and then have it match it up with the model and see whether or not it gets it right. That's what it does. But since we have a simulator here, I can't do that. And so I have to pick photos, and I'm just going to pick photos from ones that I already did that with. And here they are in the gallery. And here's some waves. Here's some victories. Here's a thumbs up, a bunch of okays, got a power symbol, and a thumbs up, and a couple of victories. So I'm going to go ahead and pick, an OK. And it's going to chew on that and compare that to the model and see whether or not it gets a match. And it does. It knows that that's an A-OK. I'm going to do that again. Okay. Let's pick this A-OK. And it's going to chew on it and compare it. Oh, it didn't get a match. Well, the truth is, this is not a perfect model. This model works sometimes, and other times it doesn't work. But let's give it another shot. I'm going to pick the victory sign here. And it's going to chew on it and compare it. And it's victory or peace. Peace is good too. And so it got this correct. So far we've got 2 accurate signs. That's not bad. Let me do one more. Let me do this thumbs up. And there we go. It knows that. So that's really not bad at all, considering how little time was put intentionally put into the model itself. And so I'm going to show you how I built the model now. So the whole key behind building a model is, now I did this before. Does that look funny, or does that look okay?
It looks like it's floating around.
Yeah.
I could see the peace sign get dragged over. Now it seems like it's going better.
All right, good. Okay. So do you see the background, the white background?
Yeah.
Yeah.
Okay. So what I'm doing here is, this is just a video of how I'm actually training this up with pictures from an Android phone or from an iPhone, whatever you want. And then you load them up into the model. You train the model up using these images. And you need a lot of them. You know, just like 5 or 10 isn't really enough to have it be able to learn. Just like anything, you need, like when a kid is really young, you have to show them the same thing over and over and over and over again. It takes a while. Machine learning is not as smart as people. And so even if you show them 10 things, that's still maybe not quite enough. And so you might need to show them as many as 20 or 30 or 50. And then it will eventually, slightly different ones. These are all, you know, the idea is that they're all slightly different from different angles. What you really should have is more variation than this. You should have them from the left hand. I actually did train the left hand. And then you should also train it with different colors in the background and more angles than I've got here. But I wanted to keep it simple. So what I'm going to do is create and train up a model in a really easy UI. It's called Azure Custom Vision. We're going to create the project. We're going to upload some images, and then we can train up the model. And then it reviews its own performance. So this is something that you can go ahead and go up and use, which is customvision.ai if you want to write that down. And this allows you to do 2 projects for free. So you have to keep deleting one. And I'm going to type in my project. The most important thing here, project type, classification, I'm sorry, object detection. No, that's not right. Classification is right. And then I want to do multi-labels, because sometimes I want to be able to give it more than one, give each hand more than one label. The most important thing here of all these things is that it's got to be compact. They have different algorithms that identify these different things. Like if you happen to be doing food, pick the food one, because it'll train better. If you happen to be doing landmarks, you know, outside, pick landmarks one, because that'll train better. But you've got to use compact, or else it will not be small enough to or compatible with Tensorflow Lite to use on a phone. Okay, so I'm going to create that project. Now, the next thing I need to do is add images. I'm just going to do that from my own computer. I've got them. And I have them in a folder such that I have them in folders by the label. So I've got a folder full of AOKs. And I'm just going to take a few of them. I'm just going to take 5 of them. Ordinarily, you'd take them all. But I want to make good use of your time here. And then you remember the label? Here's where we put in the label. Okay.
And you're only uploading 5 images, or did I miss something? Okay.
I'm only uploading 5 images because I don't want it to take an hour.
Okay, right? That makes sense.
So you want to upload as many as you can. And you can see here, we've got, they're all slightly different, just ever so slightly different. And then this really is a dumb, simple program. And they really did wrap this up nice for us. We click the train button. That's all you need to do, quick training. And it uses those images and then trains on those images. And so that's going to take a minute or two. With 5 images, it shouldn't take very long. But I'm going to go ahead and let that run. And while that's running, I'm going to show you the next step.
Out of curiosity, whenever you're doing anything like machine learning wise, is there like certain requirements in terms of hardware you should be using? Or in the case of, what is it, custom vision, does it kind of outsource the processing or something like that?
Well, custom vision is doing it on its own servers, so you don't have to worry about it at all.
Oh, okay.
If you're doing your own thing, which I'll show you how to do in just a second, on your machine, a lot of times it uses the graphics card.
Oh, so having a good GPU is important.
That's right.
Okay.
That's exactly right. So this is still churning away, and then what it's going to do is create a model, and then we export that model, and we put it in our Visual Studio solution right there in our platform specific folder, or in this case it's in the Android folder under assets, and the name of it in this particular case is model.tf Lite for TensorFlow Lite. And that model is pretty small. That model is like about 3 meg. It's really tremendously compact.
Was that model generated from the last step that you just did?
Yep, we're waiting for this to finish, and then there's an export.
Oh, gotcha. Okay. Yep.
Yep. So let me walk through the code here. So here we have on our main page, we've got our take photo, we've got our pick photo, and those are bound to commands, take photo and pick photo. And here's the view model. And take photo, we talked about what it did, but what we did was to use pick photo. And so they both call handle photo. So I'm going to go over into handle photo. And this imports the photo. That's what this thing does. And then when it's done, it calls classify. And then when classify is done, it calls classifier classification completed. Now you can see what this thing does is pulls the results back out of the predictions, and it sees whether or not the probability is, now this is very low, just so you know, is above 40%. If it's 40% certain that this is the hand, that it got the classification of the hand right, then it's going to go ahead and print the tag name, that is the AOK or the victory, and then I have specific hand images that you saw with that have a white background, and so that's a success right there. And then the no match, you saw one of those. That no match JPEG is that big red circle. So what is this thing doing? Well, it's calling classify, and classify is over here. It's in TensorFlow classifier. And this is setting up what it calls an interpreter. And this is passing in the model. And the model is just mapped byte buffer of that file that we just talked about, model.tf Lite. So it has the model. You put it in the interpreter. You have to set up a few parameters, and then you run the interpreter. And one of those parameters that comes in is your photo. And then it produces a result, which it brings back, here. Fires classification completed. and then checks the result to see whether or not it's above 40%. If it's above 40%, it displays it. If it's not, it says no match. So that is the application, and that's how it works. Are there any questions about the app?
Yeah, out of curiosity, can you go back to, what was it, the first, the the main page XAML file? Yeah, that one. Out of curiosity, for that part you have highlighted the command equals binding. I'm I'm doing like a simple tutorial on Microsoft, and they're starting to use the X bind format, but it's only for like a read-only type of format. Is that like when you use binding, is that just like for two-way binding, or would it even matter in this case?
Well, in this particular case, it's a command. And so it's
Hmm.
not so much about a data binding
Okay.
as it is about running that particular method.
Okay.
And so that's what it's binding. It's binding to that method.
Oh, okay. And that happens when you just click on the picture, right? On the main or when you click on the take photo.
That's right.
Okay. And for
Just a
pixel.
part of a button.
Okay. And are the methods called for both of those, take photo and pick photo, pretty much the same, or is it different? Because I mean, isn't it the same process if you whether you take a photo or pick a photo?
Well, the handling is at the end of it, when you're done with it, you need to be able to handle it the same way. But
Oh, okay.
one of them is pulling it from your from the camera where you take a picture, and the other one is pulling it from your camera gallery where you pick a picture.
And does Xamarin take care, I guess, of the like back end of like communicating with the phone in terms of getting access to someone's camera or photo? Or is that
No,
something as we as developers have to incorporate?
you've got to do that yourself, and you use a plugin of some kind or a library of some kind. You might want to look at Xamarin Essentials because I believe that covers that base. We
Okay.
use something called cross media. Um, I use cross media here, but you would look at Essentials first.
Okay. Cool.
Now, along those lines, I've used like Azure's ML Studio before. Have you used that at all, or how does that compare to what you had said?
I'm familiar with it. It's a pretty sort of industrial strength version of. I mean, it dumbs things down like this does, but it also gives you a lot more options and a lot more control. It's for serious enterprise shops that are doing ML, where
Oh,
they don't want everyone just doing it in Python.
okay. So, and this tool here is just a quick tool to use to generate your models.
It generates the model.
Yeah,
It's good for prototyping.
excellent. All right, cool.
All right. So any more thoughts on the code itself? All right. So the next question here is let me first talk a little bit about the ML landscape. And actually, you brought us in with a good lead into this,
Yeah,
Russ.
how about that? Right there it is.
Yep, there it is right there. So they have a lot of different ways in which to approach this. And every few months, they come up with something slightly new. If you're really super new to this and you haven't done it at all, check out Azure Cognitive Services. Those are awesome. And it's almost all online. You can just sit there and use ML models that are already trained, and you can see how they work and the types of things that they do. And they have them not just for visual, but they have them for text and for search and for audio and for all kinds of things. So check out Cognitive Services if you just want like an ML 101. And then machine learning is, this is uh, this is like Entity Framework. This is like a little higher end. It's not as good for developers to learn machine learning. I've never heard anyone say that that's what it's for. But companies are using it once they get into this seriously, and they need to manage all of their models. That's what you want to start using Azure Machine Learning for. In the meantime, we have things like ML.NET, which allows you to use just an ASP MVC or UWP or just a command line in order to use a library that handles the models for you. And so I encourage you to take a look at that if you want to start getting serious in the .NET ecosystem. And then Loeb is a company that actually was just acquired last year, or maybe earlier this year, by Microsoft. And that's a company that does something like what we just saw, but much, much more in depth. And so they're still trying to figure out what to do with it. You can get onto the beta if you want. I think it's Loeb.ai, and they have some really cool stuff in there for visual cognition. So that's the landscape at Microsoft right now, and it'll change in a quarter, but that's what we have today. And so what we used for ourselves was something a little bit simpler, which was Azure Custom Vision to build that model, and then Tensorflow Lite. And you know, I didn't, here, I want to show you. Tensorflow Lite is a NuGet package. So you browse Xamarin.TensorFlow and you'll find it.
And out of curiosity, was there a specific reason you chose TensorFlow as opposed to other, I guess, what is it, like large data processing software or packages? Because isn't there like Hadoop and other stuff, HDFS, I think it's called?
Well, you need something that's going to run on a device, something that's designed to run on a device. Like Hadoop is not something you want to be running on your phone.
Oh, okay.
And so they put this together specifically to be run within Xamarin on your phone. And so TensorFlow is something that I knew I wanted to be working with, and I'll show you why in just a minute.
Okay.
But that's what this is about. It's the light that's key. All right. So at this point, we can take a Q&A, take the blue pill, or we can take the red pill, and I can bring you down into a TensorFlow example of this exact model using neural networks in Python.
Let's open it up for any questions. We had a couple of people that joined us after we did our intros. We had Esteban and Dingbats XR and Robert Helstray. So Robert, you want to just say hi real quick?
Sure. This is Rob Helstray. I work with C# Xamarin for iOS and Android projects. Currently working with JM Family in Deerfield Beach, Florida. And I think Dan actually spoke at our user group back in 2014 at Nova Southeastern in Fort Lauderdale.
That's right. Just a Saturday. All right. Well, good to see you again, Robert.
And who's next? Anybody else want to go? We had, how about Esteban? You want to say hello? You can unmute yourself there.
Hey guys, this is Esteban. Nice to meet you all. I'm from Costa Rica. I'm watching this. I was in Florida a couple of times. Great resources, great meeting so far. Working with Dan. I was in contact with him some years ago as part of the MVP program. So awesome session.
All right. Thank you, Esteban. It's great to see you again.
And Dingbats XR. Love the name. We got no, should be unmuted. You want to speak up, say hello. Okay, I guess we'll pass on that one. Yeah, Dan, I think just dive right in, huh?
All right, we'll do. Okay, so this is the rabbit hole. And so this takes us down into Visual Code. And so we're not in Visual Studio anymore. We're on Kansas anymore. So we're now in, this is, Visual Studio Code has within it lots of different types of sort of, not so much templates, but environments. And the environment that I'm working in is Jupyter, Python within Jupyter. And so this is all Python that we're looking at, but these little modules that it's in, these little cells, this is Jupyter. And so if you've seen Jupyter before, you know that you could run each of these cells individually, which is super cool. So I'm going to run the import. So that's going to import the models, or not the models, I'm sorry. It's going to import the libraries, TensorFlow, and then Path Library. These are something that we need in order to make this work. And then I'm going to go ahead and tell it where to find the images. And then I'm going to create a data set using something called TensorFlow.Keras preprocessing.image dataset from directory. Now we're in a Keras library, which is a library that sits on top of TensorFlow that, and its purpose is to make neural network model building easy. And that's what Keras does. And so it lays on top of TensorFlow. TensorFlow is a little closer to the metal. Keras is a little bit more distant, but gives you an API in order to be able to easily build these things. And so I'm going to build this thing. I'm going to pass it in as a, let's see, it's a training data set, and I'm going to go ahead and run it. And it found 140 files, and you saw those 140 files. Those were those hands, 140 images. And then it's going to use 20% of them, the validation, 20% of them for training. Now I want a separate validation set so that we can compare to it at the end. These validations up here, that's used for the training itself. But at the end of the training, I want to be able to have it compare. So I'm going to take some of those images, subset validation, and sorry about all the pop-ups, using 28 files for validation. So we've got 112 for training and 28 for validation. So there we go. Now we're ready. We're ready to train a model. And so I'm going to go ahead and run a few of these things. Basically, they're just going to look at what we just did to make sure that it makes sense. And so we count up the images, we get 140, just a sort of a double check. And in this particular instance, we have 4 labels. And we're just looking at the first image just so we can see that it's something, so that we can see that it works. And so there it is, it works. And then we look at the class names. And so it wasn't 4, it was 5 with 0 indexing. AOK, power, thumbs up, victory, and wave, you've seen them. And so these are the labels. And now I'm going to go ahead and let's look at the first 9 or so validation images. Now we shuffled these up, back up in the validation. We set shuffle to true. So that means that we get a kind of a random seed of validation images. So we're not going to see all the same one if this works. We're going to see different ones. We're going to see 9 different images. So these are the beginning of our validation images. So we know that we're on the right track.
I'm sorry, what do you mean by validation images again?
So there are 2 types of images, 2 types of data sets that we just put together. One is the training data set, and that's the data set that's going to be used to train the model. But then we need to double check it at the end to see whether or not any of that training worked. And so for that, it's like a test set. It's the validation set. So that's why we need 2. And you'll see it in just a minute. You'll see how those statistics work.
Okay.
Also, Esteban had a question about, can we grab your code and try it ourselves somewhere? Do you have a repo at all for this?
At the end, I do have a GitHub.
Great.
There's GitHub, yeah. It has the Visual Studio project in it.
Okay.
Okay, I'm gonna run it.
This is really cool. All these steps are step by step in here.
It's nice, isn't it?
Yeah.
And so here is the building of the model itself. Now, I'm not going to get into what all of this means, but what's important is that these are layers. here's this, that grouping, that's a layer. This grouping, this is a layer. Remember those columns of dots that were connected with different lines? Each of those columns of dots is a layer. Here's another one. And this is called a convolutional neural network because it has 3 layers of convolutional neural networks. Leaky ReLU is a particular type of algorithm that works really well with cognitive visual. And then, so this first one has 128 nodes. This second one has 64 nodes. This third one has 32 nodes. And then the final one, the exit one, has 16 nodes. And I'm going to run this. And when you take the nodes and you put them in different combinations by connecting them, you get what are called parameters. So this level gives us 3,584 parameters, 3,584 parameters. There are a lot of connections to this next level, which gives us 73,792 parameters, 18,000, et cetera, for a grand total of 9,830,416 parameters. So when you put that many layers in, I mean, that's actually quite a few layers. It's not shabby. You get a lot of brain power, to put it that way. And so that's what these parameters reflect, is the potential for learning is what these things are. So now I'm going to go down into training the model. Any questions about the model itself? Because that's a model.
One question. When can you go back up to the layers? So that alpha against parameter, am I correct in thinking that's alpha in terms of like statistics? Is that what you're trying to kind of, I guess, prove using your null, or is that just something different completely?
Well, it's a parameter that we have to pass in to the leaky ReLU algorithm.
Oh, okay.
Yeah.
Okay, so that's something to do with the algorithm. That's okay.
That's right. All right, so we've got our model, and now it's time to train it up. We have a compiler, and we have to put in particular loss algorithms. Here, these are yet more algorithms that you get to learn about when you get into this, and they don't make any sense until you figure out certain ones work better for certain things. But it's an art, not a science, so you have to try different ones sometimes. And then we do model.fit, this is actually the training line right here. And this is important because you can see here is our training set, the data set. That was the set that we set up top. And then here's our validation set, the second set. And so then we have
the data set, is that the one that got split out, or is that the entire data set?
The data set is the training section.
Training things. Okay.
Yeah.
All right.
And then epochs, and here's epochs is set to 12. That's really the number of passes, the number of training passes. And the more of those you have, the more it tries to train itself.
It's a good name.
All right, I'm going to go ahead and run that. Now it's starting with epoch number 1. And it's very low tech, but you can see that it's running through it. That's a progress bar. That took 13 seconds. Now, I'm not going to get into what loss means, but loss is important for your accuracy. What we're going to look at here is accuracy itself. And so when it's training, it estimates how accurate it was. And then when it's done an epoch, then it compares it against those validation values that you saw. So the most important number here is validation accuracy. And here it's 0.1, 10%, or 11% if we round. Here it's 18%, 7%, 10%. All right, and this is going to continue to run. And then when this thing is done, you're going to want to tweak it. And so you tweak what's in here. You might want to add some more data. I mean, the first thing, so I worked on this actually in a deep learning class that just ended a couple of weeks ago. This was one of my projects. And so I went through this and I determined there's all kind of tweaking that you could do as far as the different types of algorithms and the number of nodes and the number of layers. But the bottom line is, guess what this thing needs?
More data?
More data. This has so little data that it really doesn't even barely qualify. It's amazing that it works. But again, I didn't want to spend a week on data. I wanted to see what could I do with my camera in one hand and coding with the other. And so if I were to want to improve this, I would want to stand up against that wall and take another 1,000 pictures. So this is still,
I guess that's where like being able to mine data successfully is a useful skill to have, I suppose.
absolutely for this it is. And so this is creeping up to 32%. Actually, that should be creeping up to like 47%, but maybe I changed something before I got into this. When I was working with this earlier, this was creeping up to 47%, which is over the 40% that we needed in our code. And then what we do is give it a directory and we export it. So at the end of the day, this has the exact same file name as the one that came out of Custom Vision.
Right.
And you do the exact same thing with it. It's no different at all. It's a TensorFlow. Okay, here, let me go back to it. How do we export it? Using Tensorflow Lite converter from Keras. So it's already in the right format. It's a .tf-lite file. So it's a standard format file. And we drop it in here and we use it. Now, the truth is that the one in Custom Vision is actually quite well tuned for cognitive vision. And so this works, as you saw, reasonably well. We revisit it one more time. I'm going to pick the power fist, and it's going to compare to that model. And there we go. So it performs unusually well for the amount of data. This one does not perform quite as well. And so I could probably stand to spend a little more time with it. But the one that I'm using in the app right now is the one that came out of Custom Vision. All right, I think that covers everything.
That looks like a great tool, Dan. I put a note into the chat window for everyone to type their name and email in a private chat to you, Dan, and you'll do a drawing from that for your book. And does anybody else have any questions for Dan before he wraps up?
Yeah, out of curiosity, can I see what your code was for the take photo method back in the for the code in the SAML view?
Sure. I mean, I'm happy to show it to you. I would recommend that if you're the first time at this, that you use Essentials. But I'll show it to you.
Essentials? Okay.
Yeah.
So is that just so does that method come in the assembly, I guess, of Essentials?
Um, Essentials is a NuGet package. Xamarin
Hmm.
Essentials is a NuGet package, and it should have a cross-platform uh, photo take and photo gallery option.
Oh, okay, okay, I see what you're saying. Okay. So that's okay. Never mind then. All right.
Yeah, yeah.
Cool. That's awesome. All right.
All right. So if you would like the book, just shoot me your name. If you would like to be on, if you like the book and you'd like to be on my email newsletter list, then please shoot me your email address. Either way, you'll be in the hat for the book.
And anything else you got for us, Dan?
I think that's it. We've got a GitHub repo that
Oh,
has
there it is. Okay, yeah.
the Visual Studio repo. It doesn't have the Python, but it's got everything else. I'll get the Python up there soon enough. I want to thank you for the opportunity to speak for you folks. You've been great.
Oh, this is great. Really felt good to have a meeting with some Xamarin content today. So I appreciate you helping us get this group kickstarted again. And we'll try to get these meetings done at a monthly cadence now going forward. And Dan, I just really want to thank you once again, out of my heart, for putting your time together and this great presentation. It's a fascinating area, that's for sure. And now we can all watch the movie on Netflix called The Social Dilemma. And it's about how all the AI and machine learning that has been done on